Okay, hi guys, it's me, the Master 316, and today I'm going to be doing a chemistry video on one of the booklets that we were given for homework. So this is exercise 5, the practical, determining the relative molecular mass of a volatile liquid. So let's start. So on the first page, just highlight any important bits. So as you can see, we have been given a temperature and pressure. So there's pressure, there's temperature. So just make a note of that in case we might need it. So yeah, you can read over it. So let's just see what the first question is. So draw a best fit straight line on your graph. Okay, where is my equipment? Here it is. So let me get a ruler. Preferably a long one, but I have a short one, so that doesn't matter. So, well, it has to start through the origin, we know that. So it has to go up through here, can you see it? Anyway. And then it has to go through majority of the points. So let me just draw it out how I would, and then see how it is. So as you can see here, it's a straight line, perfectly through all points except one. You can see that one in the middle. This one is a bit off, so you circle that, and that's your anomaly because it doesn't fit on the graph essentially. So now let's go to the next question. So use the graph to determine the volume of gas which would have been produced at 0.1 grams of X. Okay, so we're going to have to read off the graph, read off the axis. So you have mass there, we're looking at 0.10, and we need to find out what it is. So let's do it. So 0.10, can you see, is here, and we need to read up and go up along till you get to this point here and read off. So it's about 47 to 48. I don't know if you could see that, but that's where the 0.1 is. You read up along here and go along the side till you get to your y-axis, and then you look at what you get. So that was about 48. So I'll write that down in the next part of the question. So volume of gas is 48, was it centimeters cubed? Yes, it is. So state the ideal gas equation. So this is something you should know. PV equals nRT. If you're not sure, then P is pressure, V is volume, N is number of moles, R is the constant given to you, and T is temperature. So use your answers to part 2 and part 3 to calculate the MR of X. R is equal to 8.31 joules per Kelvin, I think it is, so, per mole. So now let's see what we need to do. So let's work out the number of moles first. So PV over RT is equal to N. Can you see? Yep. Okay, so now let's sub in our value. So 100,000 times by the volume. The volume is 48, but this is in centimeters cubed. We need to convert it, obviously, to meters cubed. So if you don't know how to do that, then just learn the equations for them. I'm not sure what they are, but all I know is that to get centimeter cubed to meter cubed, you times by 10 to the minus 2, I think. So because now we got cubed, we have to times that by 10 to the power of minus 6. Not sure about this part, but I think that's right. And now divide all of that by the constant given, so 8.31 times by the temperature given, which was 373, if I'm correct. Let me just go back. Yes, 373 Kelvin. Just a note, to change from temperature, from degrees to Kelvin, you add 273. So if it was 20 degrees, then you'd have to add 273 to that, so you get 293 Kelvin. So that's just how it works. Let's plug this into a calculator and see what we get as our answer. So 100k times 48 times 10 to the power of negative 6. Again, I'm not sure how to really explain this part to you guys, but if you know it, that's good. If you don't, then you just need to memorize it, because I'm not too sure of it myself. So for moles, I got it being 1.5 times 10 to the power of minus 3, but that's two significant figures. I need 3 or 4, so let's just put 4, 8, just here. So now we've worked out the moles. Let's see what we can do. So moles is equal to mass over MR. So moles equals to mass over MR. So mass over moles will give us the MR. Now we need to sub in what we've got. So the mass is 0.1 grams. Divide that by the moles, which is 1.548 times 10 to the power of minus 3. Again, it might be a rounding issue. Can you guys see it? Yeah. So I'm gonna go a bit off the page, but 0.1 divided by 1.548 times 10 to the power of negative 3. Let's see what we get. I got 64.6. What the hell did I just do? Okay, wait. I put 64.g. So 64.6 as the MR. So again, that might be a bit off. I'll check the mark scheme. Maybe I'll mark it now after this. So now we need to work out the maximum errors. So let's just move this up a bit. Okay, so we know that the balance, we were trying to measure 0.1 grams, and we know the gas syringe was out of 100, but volume of gas given is 48. So what we need to do is we need to do 0.01 over 0.1 times by 100 plus 1 over 48 times by 100 to give us the total percentage error. So now we need to type this into a calculator and see what we get. So 0.01 divided by 0.1 times by 100 is 10%. So that's quite a lot of uncertainty. Plus 1 divided by 48 times by 100 equals to 2.083. So the total percentage error, just write the percent signs. The total percentage error is going to be 12.1 to 3 sig fig. It doesn't specify how many significant figures, so I'm going to put it to 3. So now we're on the evaluation part. So here we go. So consider the graph and comment on the accuracy of the results obtained by the student. Is your line of best fit good enough for you to use with confidence? Identify any anomalous result. So we can say that the points on the graph, I guess, what can you say? So the points in the graph lie on the line of best fit. Except for one. Now we just need to state which one that was. So that one was this one, as I said. So that's 0.9 grams of mass. So we need to state that. Which had 0.9 grams of mass. Let's see what else we can say. It's good enough to use with confidence. Let's see, is there anything else? So that except for one, maybe I should just put a comma and put lowercase, which I just did. Okay, so except for one, which had 0.9 grams of mass. That looks good enough. Obviously I might lose a mark because I might have missed something out, but let's see. So the correct value for this relative molecular mass is 72. Calculate the percentage difference between the student's value and this correct value. Okay, so that's 72 minus, what did we get, 64.6, I think. Yep, 64.6, and that's equal to 72 minus 64.6. So that's 7.4 difference. So you have 7.4 divided by 72 times by 100. I'm not too sure, but I do believe that's a 10.3% difference. I have to double check this. So yeah, okay, apart from the loss of liquid during transfer of gas syringe, identify one other source of error in this experiment. Suggest one improvement to minimize the source of error. Okay, so source of error apart from the loss of liquid during transfer. Okay. I'm not too sure about this. Maybe it has something to do with the mass. Maybe weighing it. Okay. So we know they've accounted for volume. Yeah, that's fine. Okay. So apart from the loss of the liquid, identify one other source of error in this experiment. But the thing is, there wasn't really a source of error because all the points seem to coincide with the line of best fit. Maybe I'll skip this one for now. So would a loss of liquid during transfer to the gas syringe result in a lower value for the MR of liquid X? So that means if using PV equals nRT, therefore if we have a lower value of V, then everything else is going to be reduced. Therefore the moles would be reduced. Okay, so yeah. So if you can see, so V would be reduced, which would would it? Would a loss of liquid during transfer to the gas syringe result in a lower value for the MR? It should do. So yeah, V would be not produced, reduced. So the amount, that's what we should say. So the amount of V would be reduced, which would reduce the moles worked out, amount of moles. This would give us an incorrect answer, and it would give a smaller value for the MR. I don't know if you can see that. I haven't checked the screen. Looks like the MR. So the MR. So maybe this one I'm a bit stuck on. So let's see if we can work it out. So apart from the loss of liquid during transfer of the gas syringe, identify one other source of error. So I'm not sure about that. Maybe that one I'll leave. Maybe I might be able to check the mark scheme now. Okay, so I was right about the mass. So I just saw that. So I'll do it in red pen because obviously I checked the mark scheme. So source of error was mass wasn't accurate enough. So improvement, use more accurate scales, or use I guess like a set weight, or something already measured, mass already measured correctly. Another point I forgot to mention up here at the top was that it went through the origin. So line past origin, but I checked